Hey guys, welcome back. Today is day 13 and we are going to learn how to translate inequalities. So kind of focusing on word problems for inequalities. So the warm-up that we had today, if you want to go to Schoology and print it out and try it before we go over it, you can do that. But I'm going to start by going over this. So we start out and we're solving and graphing each of the following inequalities. So we start out by distributing. Okay, and I got negative 2x plus 2. I want to move the variable to one side by adding 2x to both sides. And when I do that, the 2x cancels out on both sides, and I'm left with 20 is greater than or equal to 2. Well, that's a true statement, so we know that the solution is all real numbers. And we graph all real numbers by just putting a line on top of the number line going both directions. Okay, number 2, when we distribute, we get negative 15 plus 5n. And that's going to be greater than or equal to negative 40. We're then going to add 15 both sides. And when we do that, we have 5n is greater than or equal to negative 25. Okay, at this point, notice I'm dividing both sides by 5. All right, it's a positive 5, so I'm not going to flip the sign. So n is going to be greater than or equal to negative 5. Even though I'm dividing negative 25, both sides would have to be negative for me to flip the sign. So to graph n is greater than or equal to negative 5, if this is 0 on the number line, negative 5 is about here. I know I'm going to have a colored in circle and it's going to go to the right. Okay, looking at number 3. We distribute 7x minus 14 is less than 7x minus 15. All right, we subtract 7x from both sides, and when we do that, we're left with negative 14 is less than negative 15. Well, that's a false statement because negative 14 is actually greater than negative 15. Since it's false, we know we have no solution, or the null set. And we can't graph anything if there's no solution, okay? So that would be an example of no solution. All right, number 4 has a fraction in it, 3/2 n. We can solve it a couple of different ways. We could subtract 3m from both sides, or maybe we want to get rid of the fraction. By multiplying by the lowest common denominator, both sides, we can get rid of that fraction. So I'm going to multiply both sides by 2. All right, so when I do that, I get 16, and that would be 2 times 3/2 would be 6/2, and that would be minus 3m. That's going to be less than or equal to negative 4 plus 6m. I'm going to subtract 6m from both sides. And when I do that, I've got 16 minus 9m is less than or equal to negative 4. Then I subtract 16 from both sides. I've got negative 9m is less than or equal to negative 20. And then here I'm going to divide both sides by a negative, so I'm going to flip my sign. M is going to be greater than or equal to 29ths. Okay, or 2.222. So if I had a number here at 0 and this was 29ths right here, this would be a colored in circle and it would go to the right. Okay, so m is going to be greater than. We had to flip the sign there. All right, moving on to, we went over our homework, so you can check your homework from 12B, and we then moved to the notes. So we started off the notes identifying keywords. This table is going to be important for you to know the difference between, say, above 7, greater than 7. Sometimes we have the equal sign. If it's at least 7, we have greater than or equal to. All right, we also noted that the symbols greater than and less than. Now, if I just put the symbol up here like that, I know in the past you're used to seeing something like this, 4, and then you have a 6, and you'd say, oh, 4 is less than 6, okay? But now we have variables, okay, and we don't have numbers. So you have to understand that the symbol looks like this is actually less than, and think about when you're reading a book and you're going from left to right. You notice that little point is there. If you come to the little point first, that's less than. If you did something and you came to the opening first, the big opening, that would actually be greater than. Okay, so we've got our less than and our greater than. All right, so let's do some word problems. So Debbie has at most $60 to spend on clothes. She wants to buy a pair of jeans for $22 and spends the rest on t-shirts. Each t-shirt costs $8. So what don't we know? Well, we don't know how many t-shirts we can buy. So we're going to let X be the number of t-shirts. So that's our let statement. X is t-shirts, right? Okay. We do know that she's buying one pair of jeans and jeans cost $22. So that's our constant. All right. so is there more than one possible solution? Yes, because if she bought just one t-shirt and pair of jeans, she would have extra money to buy more t-shirts. So we want to kind of use up all our money and buy as many t-shirts as possible. So jeans and t-shirts can't be more than $60, but they could be equal to $60 because we want to spend at most 60. So that means we can spend 60, but we want to keep it under 60. So our inequality is actually $8 per t-shirt plus the $22, and that's less than or equal to 60. So we just subtract 22 from both sides. And when we do that, we get 8x is less than or equal to 38. Okay, so then we have the 38 and we divide both sides by 8. And when we do that, our x is going to be less than or equal to 4.75. Okay, but it doesn't make sense, okay, to spend 0.475, buy 4.75 t-shirts. And we can't round up in this situation because 5 t-shirts we wouldn't have enough for. So you got to know to actually round down in this situation, and she can buy at most 4 t-shirts. Okay, so there's our answer there. She can buy at most 4. All right. If Paul's age is 10 years less than 5 times Ken's age, if the sum of their ages is greater than or equal to 26, okay, let me move this over. Whoops. It's just not moving for me. Hold on. There we are. Find the youngest possible age of each boy. So we're going to start with our let statement. Since Paul's age is 10 years less than 5 times Ken's age, we don't know Ken's age, so let's let K be equal to Ken's age. Because notice now we can actually come up with an expression to represent Paul's age based upon Ken's age. And we do that by saying it's 10 years less than 5. So 5K minus 10 would be Paul's age. All right, if the sum of their ages, so we're taking the sum of their ages, we're going to add them together, and if it's greater than or equal to 26, okay? So if I take Ken's age, which is K, and I add Paul's age, which is 5K minus 10, I should get that greater than or equal to 26. So I combine my like terms, all right, I move the constant to the other side, and I get 6K is greater than or equal to 36, and then I divide by 6. So K is greater than or equal to 6, okay? So it's saying, what's the youngest possible age of each boy? Well, Ken's age would be 6 years old, and Paul, we take the 6 and plug it in. 5 times 6 minus 10, we would get 30 minus 10, which is 20 years old. So Ken would be 6 years, and Paul would be 20. Okay. All right, let's look at the next one. Mrs. Stevens has a certain amount of money in the bank. After she deposited another $350, she had at least $1,170 in the bank. What's the smallest amount of money Mrs. Stevens had in the bank before her latest deposit? Well, our let statement is their starting amount. So let's just say S is our savings. We don't know what we're starting with. But since she deposited it, we know we add 350. So if we take savings and we add 350 and we want at least 1,170, that means it's going to be greater than or equal to 1,170. Okay? So from there, it just becomes a simple solving. We just subtract 350 from both sides. When we do that, our S is going to be greater than or equal to 820. So she had at least $820 in the bank to answer the question. All right, you always want to answer the question that the problem's asking. If we look at the third one, Mary decided that she would not spend more than $275 for a new coat and dress. If the price of the coat was $15 less than 3 times the price of the dress, what's the highest possible price of the dress? Okay, so let's see. We know if we know the price of the coat, but we don't know the price of the dress. So let's let D be the dress. And see, we can now represent the coat relative to the dress. So the coat is going to be 15 less than 3 times the dress. So let's multiply 3 times D and then subtract 15. Because remember, that then tells us to take it after. Okay, so we have the dress, we have the coat. All right, we want to put them together because we don't want to spend more than $275. So we take the dress and we take the coat and we want to keep it under $275. All right, because she can spend $275 for it. We combine our like terms, 4D minus 15 less than or equal to 275. We add the 15 to both sides, and we get 4D is less than or equal to 290. And we divide by 4, and when we do that, our D is going to be less than or equal to $72.50. Okay, so the highest price for the dress is $72.50. Okay, all right, let's move on to number 4. Number 4, a movie theater sells adult and child tickets. If at one showing last week, 200 more adult tickets were sold than children's. Okay, 200 more adult. What's the smallest number of each type that was sold if the total number of tickets was at least 500? All right, well, let's start with our let statement. So let's let C be child tickets. We can write our adult tickets relative to this. So we can say children plus 200 is adult tickets. Okay, but if we added them together, okay, if we take children's ticket and adults, all right, and we want them to be at least 500, so it means it has to be greater than or equal to 500. We combine our like terms. We subtract the 200, and we get 2C is greater than or equal to 300. We divide by 2, and C is greater than or equal to 150. That means we've got 150 child tickets, and then we take 150 and we add the 200, and that's how we get 350 adult tickets. Okay. All right. Number 5, the length of a rectangle is 10 inches less than 2 times its width. If the perimeter of the rectangle is less than 160 inches, find the maximum width of the rectangle. Well, I always like to draw a picture when I have shapes. Okay, so we're finding the length is 10 inches less than 2 times the width. Okay, our let statement, we don't know what the width is, so let's let W be the width, but we can write the length relative to the width. Okay, so our length then is going to be 2W minus 10. Okay, so we have an expression for that. All right, now if I drew a picture and I put the width on here, if this is the width, this is also the width, and the length is 2W minus 10, okay, the perimeter is when you add up all the sides. So you could take the 2 width sides and then add in the 2 length sides, and it's less than 160. So we combine our like terms. WW is 2W, 4W. We got 6W minus 20 is less than 160. When we add the 20 to both sides, we get 6W is less than 180. And then when we divide by 6, our W is less than 30. Okay, so the maximum width is less than 30. Max width is less than 30 inches. Okay. All right, our final example here. All right, Susan received grades of 86, 90, 95, 92, 98 on 5 math tests. What's the lowest grade that Susan can score on the 6th test for her average to be greater than 92? Well, if you recall with averages, you take all of the numbers, 90 plus 95 plus 92 plus 98. And then, all right, we have an unknown. So we have, let's call it T, okay, for the test grade. Let T be the 6th grade, 6th test score. Now to find the average, we're actually going to take all of those and divide by 1, 2, 3, 4, 5, 6. And that's going to be greater than 92. Okay, so here we're dividing by 6, so let's use the golden rule of algebra. Let's multiply both sides by 6 to get rid of that denominator. So when I do that, I've got 86 plus 90 plus 95 plus 92 plus 98 plus t, plus t. That looks kind of funny. Let's fix that. Plus t. Come back. There we go. Now it's not working. There you go. Plus t. And that's going to be greater than 92 times 6. So 92 times 6 is 552. We combine our like terms, which are just the constants, and we get 461 plus t is greater than 552. And then we solve for t. Minus 461. When we do that, t is going to be greater than 91. Okay, so she needs to score a 92 or above. All right, because she can't score a 91, it's got to be greater than 91. So actually, it could really be like 91.1. That's fine too, as long as it's greater than 91. Okay, I hope this helps. So go back and try to do your homework now. Bye.